Hi everyone, today we're going to continue to talk about some topics that are going to help us to solve quadratic equations. The first is simplifying square roots or radicals. Radical is the actual symbol here. When we're doing a square root, then we can call it a square root, but radical symbols can actually be used for cubed roots, fourth roots, fifth roots, etc., which we will get into next semester. For now, we're doing square roots. So to simplify the radicals, we want to bring out any perfect squares or pairs of the same number. And so we need to find some hidden pairs in these numbers that are under these radicals. So I'm going to take the number 24 and I want to break it into two things that multiply to be 24. You can use anything except 1 and 24. So I'm going to try 4 and 6 because 4 times 6 multiplies to be 24. I can take 4 and break it down further because I know that 2 times 2 is 4. I can take 6 and break it down further because I know 2 times 3 is 6. Now, after we get to this step, I want to check and see if I have any prime numbers. Remember that a prime number is a number that is only divisible by 1 and itself. 2 is a prime number. So all of these are prime numbers. 3 is also a prime number. In fact, I would encourage you to write down some of these smaller prime numbers at the top of this sheet. All right, I went ahead and wrote the first several primes up here at the top. This should be as many as we will need for what we're doing today. So once we get our little tree, it's called a factor tree, but I almost think it looks more like a set of roots because it's going down and not up. But once we have our factor tree to where everything is circled because everything is a prime number, I'm going to be looking for pairs of the same factor. So I see that I have a pair of 2s. So this is a pair of the same factor. All right, and anything else that can't be paired up, we're just going to call everything else. So this is everything else. All right, so what I'm going to do is I'm going to rewrite the square root of 24 as two separate square roots. One where I'm going to multiply this 2 times 2, that pair that's the same. 2 times 2 is 4. And then I'm going to have another square root that's my everything else. So 2 times 3 is 6. Now, here's where the simplifying comes in. I know what the square root of 4 is. I know that it's a perfect square, and it is the perfect square of 2. And then the 6 can't have anything else done to it. It just kind of has to go along for the ride because it doesn't have any perfect squares in it. So 2 times the square root of 6 is my simplified form of my square root. So I can write 2 square root of 6 as the simplified form and box that answer. Let's go ahead and look at another one. Let's look at 32. So I can start out and think of 2 things that multiply together to be 32. I've got several possibilities. I could do 2 times 16. I could do 4 times 8. I'm just going to go with 4 times 8. Now, 4, not a prime number because it can break into 2 and 2, which are prime numbers, so I'm going to circle those. 8 can break into 2 and 4. 2 is prime, so I'm going to circle it. I'm done there. 4 breaks into 2 and 2. So I can circle both of those. So now I have 5 2s. Remember that I'm looking for pairs. So I have a pair of 2s here. I have a pair of 2s here. And I have this one little lonely leftover 2 that I'm going to bracket off and call my everything else. So I can rewrite square root of 32 as a 2 times 2, square root of 4, another 2 times 2, or square root of 4, and then finally that little lonesome square root of 2 that didn't get to pair with anything. So if I take the square root of 4, I get 2. If I take the square root of 4 again, I get 2, and then I'm still left with that square root of 2 that can't pair up. If I multiply these two green 2's together, I get 2 times 2 is 4, and then I'm left with the square root of 2. So my final answer for my simplified form of this radical is 4 times the square root of 2.